So yes, hard task to be the last presenter. I hope I can catch a bit of your remaining attention. And thank you a lot for the opportunity to tell you a little bit about a project that HP is an active member of, the development of the PIA tool. So this project is a collaborative research effort led by the MIT, Massachusetts Institute of Technology, and has several OEM partners, including companies you see on this slide. Other partners include the Sustainability Consortium, of course, INEMI, which is the International Electronics Manufacturing Initiative Organization, kind of a professional association, the Carbon Trust, and also the US EPA through the Energy Star body. Also involved in this project are Carnegie Mellon University, the University of California, Berkeley, and Arizona State University. So like in the Sustainability Consortium, it has the goal to be backed up in a scientific mode. This project has developed an approach for streamlined environmental assessment of IT products. And the first phase has focused on laptops. This work tries to address the tension faced in the IT sector between the complexity of IT products, the high cost of these assessments, and the urgency for quantitative information, for labeling and standards efforts. So I'm here on behalf of Elsa Olivetti, who is the project leader at the MIT, and who prepared the slides for you. So I must apologize, but I will also try myself into the PowerPoint karaoke. I do my best. So I will run fast on some of the first slides because you all understand what it is about the urgency for quantitative information, mainly through the many initiatives you can observe around the world. The only thing I want to mention here is that project doesn't forget all the standards effort and will be linked to all these standards efforts. And I've mentioned a few of them, and I will come back on this. I will skip this one because Malcolm Fox made the presentation, and you all know what is the Sustainability Consortium now. And directly jump to one of the subgroups which is embedded into the Sustainability Consortium, which is the Electronic Sector Working Group. This project is an intimate part of the activities of the Electronic Sector Working Group. It has focused on laptops, as I said, to begin with, and has recently begun looking at televisions, which is the reason why you can see some new members like Panasonic, Samsung, Toshiba. Several of the companies specifically involved in the PIA effort are involved in the Sustainability Consortium. Some other are not. However, thus far, the PIA methodology that we will talk about has provided the backbone to the electronic sector working group activities. So just to summarize the challenges and the complexity that is facing the IT sector and IT products that make the lifecycle assessment difficult and costly. These challenges motivate our work, and we are searching for an alternative approach. So you will see something a bit different from what you've heard today. So first difficulty is obviously about product data. IT products are very complex, around 1,000 components in there. And on top of this, it's a highly dynamic industry. The turnover on products is very high. So the data has to be renewed and updated very frequently. Another issue with the process data is that the supply chain is also very complex. Most of these products are subcontracted by the brands to manufacturers, what we call ODMs. And the depth of the supply chain is enormous. We consider that it's between 5 or 7 levels of contractors. So it's very difficult to get primary data. Another difficulty is the special materials and processes that are involved in the manufacturing of IT products. These materials and processes are not well represented in the popular databases that are available. So there are holes missing for this exercise. The cost and speed is also an issue. The criticality of secondary data, the usefulness of secondary data in LCA may be limited if their origins and quality are unclear. We already discussed this morning. Therefore, primary data are encouraged for LCA, which can be time-consuming and resource-intensive to procure. The actionability also is an issue. Often the product designers are very far from the supply chain issues and from the green pressure also. So it's very difficult to translate environmental information into design decisions. Uncertainty can make it still more difficult. And then the credibility, of course. Uncertainty can be significant compared to the relative magnitude of the expected impact and its variability among similar products. So, to fulfill this clear need for a new approach to these LCA techniques, we set the goals for that project. We wanted to develop a quantitative approach with the aim of providing information that can be used for designers and consumers. We limited the resolution of that effort to the product type level, not going to a finer granularity of the model or the product number, what we call the SKU. So, product type. And we wanted to focus on the hotspots, the major sustainability levers, both in terms of opportunity for action and in terms of the ability to understand what it is about. It was about also creating a prototype tool in the first phase, and we tried to make it efficient in minimizing the data collection and user input, and to make it effective in providing actionable insight. And also credible, of course. The main mechanism we have used to increase the credibility is to incorporate uncertainties so that we can understand where these uncertainties are and we can quantify them, but also show them in the results and have a statistical understanding of how uncertainty contributes to drive where more details is needed in the analysis. So, there are two major strategies that constitute that methodology. The first one is a probabilistic triage, which basically means that we start the analysis from a high level and using the uncertainty to go to those phases and components that are most critical. That first step helps us to minimize data collection in the long run. And the second step is the product, the PIA itself. PIA means product attribute to impact algorithm, where it's about developing statistical regression that translates from a particular attribute of a product to a bill of material or a bill of activity, and then to an environmental impact. We saw, we started looking at laptops and just at carbon emission and energy, But the same approach can be applied to other products and other impact categories, and that we will do in the next phases. The method is designed to be modular to enable extension to other products that share components or life cycle phase parameters like the use phase. So what is the basic principle of that approach? We talked about this tension between the urgency of calculating a result and the complexity of the electronic products and of many other products you may want to perform an LCA on. You have this effort to get to an idealized goal, which is to possess the answer, the result. And also the need to be in a reasonable vicinity of that result. But there are given resources in time to get to that result. So you need to balance between comprehensiveness and specificity in data collection, given the resource constraints. So there are two ways to get there. You can imagine trying to gain great specificity of data. Let's say if you want extensive supplier interaction in our case. You may pursue data collection for phases or components based on expert opinion, your perception of what's important, biases, etc. The problem is there is no way to know of goodness of estimate of the total system because we can't defend the impact of the omissions because there are omissions. So the confidence in the result can be relatively low. We propose an alternative. First, to start with the big picture, comprehensive, the full product, imprecise, making a low fidelity screening of entire system, so omissions are not made. And because we capture as much as we can the uncertainty in the numbers that we have got, we can use screening methods to try and get a target set of elements on which we do more extensive supplier interaction and gain more specificity throughout. And again, in an iterative process. So what are the type of uncertainties we should be certain to consider and approximate during the screening? The bill of material itself can be particularly challenging. What's exactly in there may not give a good indication of where the suppliers are, what are their environmental practices, their energy efficiency, and how that's evolving over time. Remember the high turnover rate. The use of secondary data can be challenging in terms of what are the technologies in use at the supplier, the generation of technology they are at. Variation in the geographical location of the supplier impacts on the nature of the grid mix, its efficiency, and on the transportation. All this also varies with time. For the same product, a component which was supplied by supplier A may then be supplied by supplier B in another location with another technology. So we'll look now at some results of that first step, well, in a minute, but let's first describe what is the second step, so the PIA method itself. So the basic approach to this is we've developed statistical regression based on all available data. We've got a set of most significant components for a product through the triage before. Through that statistical regression, we iteratively correlate these product attributes with associated materials and activities, from which we'll approach the environmental impact. It's a modular approach. For instance, for the laptop, we can specify attributes related to the display, the battery, the hard drive, the electronic board, the AC adapter, etc. We can look at these attributes in a way we can reuse them for other products, for instance, a desktop, or a packaging module that can be transferable to other products. These attributes we are particularly interested in developing the regressions around fulfill the following characteristics. They have a significant effect on the results based on the analysis that we have done, or they are viewed as critical by the stakeholders. Packaging, for example, is a good example of this. And also, they are knowable, meaning that we can get a lot of information around at reasonable cost. So just to look at some results briefly out of the probabilistic triage, here is the global warming potential for a laptop of a particular product class. It's broken down by phases, first of all, materials and manufacturing, use phase and end-of-life phase, and there are transport phases that are marked here with an asterisk. The color bars are representing the standard deviation with the mean in the middle, and the extremities of the segment represent the second standard deviation. That's what the originality, I think, of that method relies on. It's because the statistical approach is displayed. So this is not a particularly new or different, but we can have an understanding of the confidence on the results based on the percentage of statistical trials that indicate which of the phases are important. So in this case, 95% of the trials indicate that 90% of the impact can be attributed to the materials and manufacturing and to the use phase. This is not new, but we put a qualification around it. And we also sort of log metrics for interest, such as standard deviation over the mean, or the representation of how uncertain we are in that result. And for that particular case, it's an overall coefficient of variation of 35%. I jump rapidly to another broke down in terms of components of that result. And again, we can evaluate that for 95% of the trials, 75% of the impact is attributed to the LCD display, the motherboard, and the chassis. So from there, the work has dug into each of these components, and researchers have focused on these activities that create the most deviation. Main drivers of impact are to be understood because it's the meat for the algorithm. Just to take a simple example we are all familiar with, the use phase is being specified mainly by a duty cycle, and the relative importance of each part of the duty cycle during the lifetime of the product. And then going to another component of the analysis, like the integrated circuit impact, we see that the technology is important, the chip area, the degree of integration. So we are identifying what are the main parameters to drive that development. So what are the main accomplishments of that project? In developing the tool, we placed importance on the triage and targeted on what elements we need to gather more data around. We have seen it is possible to do some mapping between attributes and impact in order to minimize user inputs. Currently, we are testing the capacity of the method to bring the targeted level of resolution we had envisaged on different models of laptop. It's concluent at a certain degree. And I can, if there are questions on this, I can give you some more details on this. After working on laptops, we moved forward to desktops, and we are looking into the display and the LCD module itself. We are also engaged in a data roadmap. I think this is very important for primary data collection in partnership with INEMI. And Also to be noted, one of the main current endeavor of that project is focusing on looking at what other existing efforts are heading to and work for harmonizing with these efforts, be it in the IEC TC 111 committee. We are liaising through some of our partners, and also the IT sector guidance from the Greenhouse Gas Protocol. It's also a particular element we are looking to have involvement with. So important to be noted also is that there is no particular way that we set up the method that would make it exclusively applicable for carbon and energy. So we are trying to envisage, to understand how we may turn it to multi-criteria and maybe link it to some existing schemes like EPIT, which apply to computers. Lessons learned, I will not extend too much. Well, only on one, the first one, uncertainty is really significant. So I would like to thank you on behalf of the partners of that project. I can take questions. I'll try to answer some. But for the most technical ones, as I'm not directly involved in the research team, and I don't want to bring you some misleading information, I will encourage you to be in touch with Elsa Olivetti, who is the project leader, and you can see her mail address here at the MIT. Thank you.